Hi, in this video, we are going to look at some problems on hyperbola. So we'll look at some PYQs from JEE mains and try to revise the concepts that we have studied in the chapter. So let's start with this problem. This is JEE mains 2020. And it says, for some theta belonging to 0 to pi by 2, if the eccentricity of x square minus y square sec square theta equals 10 is root 5 times the eccentricity of x square sec square theta plus y square is equal to 5. Then what is the length of the latest rectum of the ellipse? So that is the question. Notice that you have a hyperbola here and you have an ellipse here. And you have to find the length of the latest rectum for the ellipse, right? So let's write the equation of the hyperbola in the standard form. It looks like this. Y square by, this is sec square theta is in the numerator. So you can write it as cos square theta in the denominator. So 10 cos square theta equals 1, right? So notice that 10 is bigger than 10 cos square theta. So transverse axis is the x-axis here. So eccentricity would be root over 1 plus 10 cos square theta by 10, right? So this comes out to be root over 1 plus cos square theta. That is the eccentricity of the hyperbola. And let's write the ellipse equation also. So ellipse equation also will be like this: 5 cos square theta plus y square by 5 is equal to 1. Notice now that the major axis is not the x-axis because here this is smaller than 5, right? So since that is not the case, right now our formula for eccentricity E dash here would be 1 minus not b square by a square by b square, right? So 1 minus 5 cos square theta by 5. So this is actually 1 minus cos square theta, and this becomes sine theta. So the key thing to understand is don't use the formulas blindly. You have to realize which one is the major axis of the ellipse, whether it is x-axis or y-axis. And if you figure that out properly, then you get the correct eccentricity here. And now the question has said that eccentricity of the hyperbola is root 5 times the eccentricity of the ellipse. So that should hopefully give us a condition on theta, right? Okay, so what we are getting is root over 1 plus cos square theta is root 5 times sine theta. So squaring both sides, 1 plus cos square theta is equal to 5 sine square theta. And we can convert this to 2 minus sine square theta also, right? Or you can convert this to 5 minus 5 cos square theta also. You'll get 6 cos square theta is equal to 4. We are getting cos square theta is equal to 2 by 3. Okay, so cos square theta is equal to 2 by 3. Now, the question is asking for length of latest rectum of the ellipse. So usually in the normal ellipse, it is 2b square by a when the major axis is x-axis, right? So one second, let me just think about it. Length of latest rectum of this ellipse. So we have an ellipse like this. The focus, the major axis is this, latest rectum is this. Focus will be 0, comma b, be, right? And if you put that in the standard ellipse, x square by a square plus y square by b square equals 1. Be, if you put, you will get x square is equal to a square 1 minus e square, right? And a square 1 minus e square is 1 minus a square by b square, right? So this becomes plus, so it becomes a power 4 by b square. So x is equal to a square by b. So you get 2a square by b is the length of the latest rectum here for this ellipse. And in this case, that will become 2 times a square, if you remember, for the ellipse was 5 cos square theta and b was root 5. So this is what we are getting, 10 cos square theta by root 5. But cos square theta has come out as 2 by 3. So this is 20 by 3 root 5. And we get basically 4 root 5 by 3. That becomes your answer for the length of the latest rectum of the ellipse. So main thing here was knowing the basic results for ellipse and hyperbola eccentricity and not making mistakes like ignoring the major axis and minor axis. If you ignore that and use the formulas blindly, you'll go wrong, right? Okay, next question is this one. This is a question from JEE 2021. It says a square ABCD has all its vertices, on the curve x square y square equals 1. The midpoints of its sides also lie on the same curve, The area of the square is being asked. The area of the square. Okay. So what we will do here is first of all try to understand this curve. This curve is not a standard curve that you have seen usually, but you can easily write this as x square y square minus 1 square equals 0, and you can factorize it as this. So technically it's a product of two equations, xy is equal to 1 and xy is equal to minus 1, both of which are basically rectangular hyperbola. Right? Xy is equal to 1 hyperbola would be the hyperbola like this. This is curve 1. Curve 1. Curve 1 is basically xy is equal to 1. And xy is equal to minus 1 would be the hyperbola like this. This is xy equals minus 1. Right? So the question is saying that the vertices of the square are on this hyperbola or on these pairs of hyperbolas. So you can have a situation like this probably. Like these are the 4 points which are vertices of the squares, right? And because all of them are lying on the two hyperbolas, we should try to use parametric form of the hyperbolas to try to figure out what we can do here. So when I say that there are two hyperbolas xy equals 1 and xy equals minus 1, the parametric form of any point on this curve would be t comma 1 by t, right? And for this curve, which is xy equals minus 1, the parametric form would be, you can write it as t comma minus 1 by t, where t could be positive, right? So if you want 4 points, you'll have 2 points on this curve, the xy equals 1 curve, and 2 points on xy is equal to minus 1. So let's write those points as these. Let's say one point is here, A, which is t1 comma 1 by t1. Here t1 is greater than 0. Another point could be here, B. This point that it will be minus t2 comma 1 by t2, where t2 is positive. It lies on the curve xy is equal to minus 1. T2 is positive, so I'm putting it in the second quadrant, so it has to be minus t2, right? This point, the third vertex, would be something like t3 comma 1 by t3, but it will be minus t3 and minus 1 by t3, right? Right. This will be the third point. And actually, like, if you think about it, I should not introduce another variable here. What I can do is I can take the reflection of t1 comma minus 1 by t1 here, because the hyperbola is symmetric about the origin. So there will be a point here which will be the reflection of this point. And similarly here, there will be a point here which will be t2 comma minus 1 by t2, right? So these 4 points I'm hoping will be the endpoints of a square or the vertices of a square. And for that to happen, I need to check the slopes. The slopes have to be 90° between any two lines, right? So product of the slopes is 90°. So let's find the slope of this line. It will be 1 by t1 plus 1 by t2 divided by t1 minus t2. 1 by t1 minus, so t1 minus t2. This is the slope of this line, and slope of this line would be minus 1 by t2 minus. So 1 by t1 minus 1 by t2 and t2 minus. So t2 plus t1, right? So this product of slopes should be equal to -1 for the lines to be perpendicular. And what we are getting from here is here we get t1 plus t2 by t1 t2. And here we have t1 minus t2. And again, here we have t2 minus t1 by t1 t2, t1 plus t2, right? So this gets cancelled. This becomes with a -1. And we are getting basically t1 square, t2 square is equal to 1. Notice that we are getting this is equal to -1. -1 gets cancelled and you're getting t1, t2 whole square equals 1. And we had said t1 and t2 are both positive. So t1, t2 product is equal to 1. That is the first thing that we are getting, right? Okay. Now, we also are given in the question that the midpoints of the all the sides also lie in the curve, also lie in the same curve. So midpoint here would be what? The midpoint here would be t1 plus t2 by 2, comma 1 by t1 minus 1 by t2 by 2, right? And this lies also on the same curve, xy is equal to 1, right? So we can do the product of this x coefficient and y coefficient and say that it satisfies this equation. So from there, we will get t2 square minus t1 square by 4 t1 t2. Because multiplying these two, you will get t2 minus t1 by t1 t2 and 4 in the denominator. This is equal to 1. And now we are getting t2 square minus t1 square is equal to 4 t1 t2. This is the second equation that we are getting, right? Okay. Now, we have already gotten t1 t2 is equal to 1. So now we have basically t2 square minus t1 square is equal to 4, right? So, okay, so this data is available to us. So what is the length of the side? Right. Okay. Let's write the data that we have so far. We have t1, t2 is equal to 1. We also have t2 square minus t1 square is equal to 4 t1, t2. Can we find t2 square plus t1 square from here? T2 square plus t1 square will be equal to because t1 t2 is 1, it is t1 plus t2 whole square minus 2 t1 t2, or okay, so from here we are getting this is 4 t2 square minus t1 square. Okay, and we are also getting that t1 t2 square minus 1 by t2 square is equal to 4 if you put t1 as 1 by t2. So we are getting a quadratic on t2. We can solve for t2. we are getting t2 power 4 minus 4 t2 square minus 1 is 0, right? This quadratic will give us the t2 square value. So you're getting t2 square is equal to minus b, so 4 plus minus root over 16 minus minus 4, so 20 by 2. So this becomes t2 square is equal to 2 plus minus, this would have been a 2 root 5, so 2 plus minus root 5, right? So t2 square is equal to 2 plus root 5 is coming from here. We have simply used these results to solve it, okay? Once we get t2 square is 2 plus root 5, so we can write now t1 square is 1 by t2 square. So 1 by 2 plus root 5. So multiply by root 5 minus 2 on top, you get 5 minus 4, 1. So t1 square is root 5 minus 2. So therefore, we know both t1 square, which is root 5 minus 2, and we know t2 square, which is root 5 plus 2, right? So now t1 square plus t2 square, you can see clearly is 2 root 5, right? So we're getting this value as 2 root 5. Why do I need this? I need this because I need the length of the side. So length of the side AB square is equal to actually t1 minus t2 whole square plus 1 by t1 plus 1 by t2 whole square. So if you simplify this a little bit, this is basically t1 square plus t2 square minus 2 t1 t2 plus t1 plus t2 whole square by t1 square t2 square, and t1 square t2 square is 1 and this is minus 2. So you have t1 square plus t2 square minus 2 plus this becomes what? This becomes t1 square plus t2 square plus 2 t1 t2 plus 2. So this is basically twice of t1 square plus t2 square, and that is equal to 2 times of 2 root 5. So this is 4 root 5. 4 root 5 is basically root over 80. So length of the side square is root 80. So area of square is root over 80. And the question asked a square of the area. So square of the area would be simply 80. So this was a little complicated because we have an unusual type of situation. The curve was this. If the curve is like this, it is a product of two different rectangular hyperbolas. Once you realize that, you have to use parametric form to reduce the number of variables. If you don't use parametric form, it will be super annoying to do this problem. The parametric form for any point here is t1 1 by t1. Because the lines are perpendicular, we can imagine that this is like a reflection here. So this one would be minus t1 minus 1 by t1, right? And similarly here it was minus t2 1 by t2, and this one was, the point here was t2 minus 1 by t2. And what we did was got a condition on the slopes of these two lines, and then we got a condition that midpoints of these also lie on the same curve xy is equal to 1. From there, we found out the value of t1 and t2 because we got two equations in t1 and t2. Once you get the values of t1 and t2, we have to find the length of this side. If you know the length of this side, you will find the area of the square. So that was the idea here. Okay, let's look at another problem. Question number 3. It says, consider hyperbola h, which is x square minus 2y square equals 4. Let tangent at P, which is 4 comma root 6, meet the x-axis at Q and latus rectum at R, which is x1 comma y1, where x1 is greater than 0. If F is a focus, of hyperbola, which is nearer to the point P, then the area of triangle QFR is what? Okay, so not a very difficult question. You have to systematically do it in a step-by-step manner. So let's say this is my hyperbola equation. The equation can be written like this: x square by 4 minus y square by 2 equals 1. This is my hyperbola. The eccentricity of this hyperbola is 1 plus b square by a square, so 2 by 4. So this is root over 3 by 2, right? If the eccentricity is this and the transverse axis is the x-axis, then the focus will be where? It will be at AE comma 0, right? AE comma 0 and minus AE comma 0. So, okay, so one focus would be at 2 root over 3 by 2 comma 0, which would be root 6 comma 0. This is the coordinate of one of the focus, right? So let's draw a rough figure here. The hyperbola looks like this. The point P was a positive first quadrant point. P was 4 comma root 6. The tangent is drawn here. Let's say it meets the x-axis at a point Q, and it also meets the latest rectum at a point R, right? So latest rectum is somewhere here lying like this. So it meets it at R here, and the focus is here, correct? You have to find the area of, see, this focus is the positive focus, which is nearer to point P, nearer to P. That is what is said in the question. You have to talk about the focus that is nearer to the point P. So therefore, I'm choosing this focus and not the other side focus. So this focus we calculated is root 6 comma 0, right? So let's first write the tangent equation here, and then we will find point R, Q, and F. And then we can easily find the area of the triangle, right? So the equation of the hyperbola was x square by 4 minus y square by 2 is equal to 1. Equation of tangent at point would be this, but the point x1, y1 is 4 comma root 6. So it would be 4x by 4 minus y root 6 by 2 is equal to 1. X minus, so you're getting x1 by a square. X1 was 4, right? Correct. So you're getting x minus y root 3 by root 2 equals 1. This is the equation of my tangent, and it meets the x-axis when y is equal to 0. So x value is equal to 1 and at y equal to 0. So this point is 1 comma 0, meets the x-axis there, right? Now equation of the latest rectum would be x is equal to root 6. This is the equation of latest rectum. If you put that in this equation, you get root 6 minus y root 3 by root 2 is equal to 1. So y value is root 6 minus 1 multiplied by root 2 by root 3, right? So this becomes root 2 into root 2 minus root 2 by root 3. So 2 minus root over 2 by 3, that is the y value, right? So basically the point R has x value of root 6 and y value of this. So the coordinate here is root 6 comma 2 minus root over 2 by 3, right? And now I know all the three coordinates of this triangle. This is clearly a right angle triangle, right? So the area of this right angle triangle will be half into RF into QF, right? So QF is going to be root 6 minus 1, and RF is going to be the y coordinate. So 2 minus root over 2 by 3. You have to do half of this, right? So this will give us the area of the triangle. So let's calculate it now. Half of root 6 minus 1, and this becomes 2 by root 6 minus 1. So basically I'm writing this as 2 minus 2 by root 6. 2 minus 2 by root 6 is the same thing that I wrote earlier. This thing, right? So I'm writing it like this. It is becoming 1 by root 6, root 6 minus 1 whole square. So that is 6 plus 1, 7 minus 2 root 6 by root 6, right? So you're getting 7 by root 6 minus 2. This becomes the required area of triangle QRF. Not a very difficult question. It was a direct application of basic tangents and stuff. Like you just find the equation of the tangent, see where it cuts the x-axis, see where it cuts the directrix, right? Okay. Question number 4 is from JE 2021 again. The locus of the centroid of the triangle formed by any point P on the hyperbola Hyperbola's equation is 16x square minus 9y square plus 32x plus 36y minus 164 equals 0. And its foci is what? Okay, so we have to find the locus of the centroid of the triangle formed by a point on the hyperbola and its foci. So point P is there and the two foci are there, S1 and S2. If you find P, S1, S2 triangle, we have to find the locus of its centroid. So we just need to find the coordinates of P, S1 and S2. This P is a variable point, so it can be written as it can be written as some H comma K and all, right? So yeah, we need to find first the focus. After that, we'll see what has to be done. Okay. So in order to find the focus, we'll have to convert this equation into the standard form. The method to convert the equation in standard form is completing the squares. So I'll say 16x squared plus 32x take together minus 9y squared plus 36y we should take together minus 164 equal to 0. Here I can write 16x squared plus 2x and plus 1. So basically I've added a plus 16. So I'll subtract 16. Then minus 9y squared minus 4y. I'll do a plus 4. So I've done a minus 36. So I should add a plus 36, right? And basically minus 164 equals 0, right? This is a minus 36 I have added. So plus 36 and this is a plus 16, right? We are getting 16 times x plus 1 whole square minus 9 times y minus 2 whole square. And this is becoming plus 20. So minus 144 is equal to 0. So we are getting the hyperbola equation as this: x plus 1 whole square by 9 minus y minus 2 whole square by 16 equals 1, right? Notice that this is a shifted hyperbola. The center of the hyperbola is shifted to minus 1 comma 2. This is the center. And if the center is shifted, you have to also realize that the transverse axis is not as big as the conjugate axis, right? So it's also like a hyperbola where the transverse axis is parallel to the y-axis, right? So let's figure out what this will look like, the foci of this hyperbola, right? So what we will get here, first let's find the eccentricity. The eccentricity for this would be a square is 9, b square is 16. So the hyperbola looks like this, something like this, right? And the center of the hyperbola is minus 1 comma 2, right? So the foci will be on the same x coordinate. Foci should have the same x coordinate here. So what we would get is we should get this point as 0 comma, usually it would have been 0 comma BE and 0 comma minus BE. Now it would be uh, -1 and 2 plus BE, -1 and 2 minus BE, right? And E would be root over 1 plus, usually it is B square by A square, but now it will be A square by B square. So this E would become 1 plus 9 by 16. So 25 by 16, E is coming 5 by 4 and B is 4, right? So the coordinates of the focus will be -1, comma 2 plus 2 plus minus BE. B is 4 and E is 5 by 4. 2 plus minus 5. So plus 5 would be 3 and minus 5 would be -3. So -1 comma 3 and -1 comma -3. These are the coordinates of my foci S1 and S2. And now I need the locus of the centroid of the triangle formed with a point P on the hyperbola, right? A random point on the hyperbola would be, let's say, alpha comma beta, right? And centroid of this triangle, these three. So we know that alpha beta satisfies this relation, right? We know alpha beta satisfies alpha plus 1 whole square by 9 minus beta minus 2 whole square by 16 equals 1. Another way to do that would be to write, instead of taking alpha beta as the points, we can take my 3 sec theta minus 1 and 4 tan theta plus 2. These are the coordinates of a random point on the hyperbola, right? P. And we have already found our foci S1 and S2, right? So that was -1 comma 2 plus 5 by 4 into 4. -1 comma was 2 plus minus BE. So 4 into 5 by 4 was coming. And 2 plus 5, 2 minus 5. -1 comma -3 and -1 comma 7. Okay. This was my foci, right? So the centroid H would be, the x coordinates will get added. So it will be -2 plus 3 sec theta minus 1 whole divided by 3. And K would be, how did I get this? I'm adding the x coordinates of this triangle and dividing by 3. Now for K, I will get -3 plus 7, 4 plus this, 4 plus 4 tan theta plus 2 by 3, right? And now it's simple only. We have sec theta minus 1 is H. And here we have 6 plus 4 tan theta. So 2 plus 4 by 3 tan theta is K, right? And now in order to find the locus, you have to do H plus 1 is sec theta, eliminate theta. And K minus 2, so 3 by 4 into K minus 2 is tan theta, right? And use the fact that sec square minus tan square is equal to 1. So we will get, basically, locus will come out like this: H plus 1 whole square minus 3 by 4 whole square K minus 2 whole square, K minus 2 whole square equals 1. So this becomes H plus 1 whole square minus 9 by 16 K minus 2 whole square equals 1. And that will be the locus. So 16 times H plus 1 whole square minus 9 times K minus 2 whole square is equal to 16. Simplifying, 16x square and 9y square you get a plus 32h here. So plus 32x, you get a minus 4k and minus, so plus 36k, plus 36y. You get a plus 16 here and a plus 4 minus 36 here. Minus 20 minus 16. So minus 36 equals 0. So finally, the locus of the centroid is coming out to be this. This is one of the options in the problem. This is JEE 2021. The question is not difficult. The main thing is looking at the hyperbola and converting that hyperbola to a standard equation. It's a shifted hyperbola. Now we have already studied all the different cases of hyperbolas being shifted. So basically, you have a standard hyperbola like this. You can shift it to this point where the center is h comma k. But it was not just shifted, it was also not a standard hyperbola. It was a conjugate hyperbola like this. Because the major axis was y-axis and that hyperbola was shifted. So that is what I did. That's how I got my focus S1 and S2. It would be on the x is equal to h line and it will be h and k plus minus be will be this point and this point, right? And once you get S1 and S2, you just have to take a random point on this hyperbola P and take the centroid of P S1, S2, right? How did I take a random point? I took a parametric form. So if I have x minus h by a square plus y minus k whole square by b square, right, equals 1, I have to say x minus h is a sec theta and y minus k is b tan theta. So the parametric form would be x is equal to h plus a sec theta and y is equal to b tan theta plus k. So that's why I was getting a sec theta minus 1 and b tan theta plus 2 and things like that in the parametric form. This is for the random point P, which is on the curve with which you have to take the centroid along with S1 and S2. I hope you have understood what we did. Okay. Fine. We will continue with more problems. Right now, I want to stop at this point. We have done a few JEE mains PYQs. These were slightly tougher PYQs from the last few years. We will do more problem solving sessions as the days go by. And what we'll be doing is mixed problems on all the chapters of conic sections. I also have to start the circles chapter soon. So I'll start circles theory from tomorrow. And we'll continue with more problems on conics as well. Circles theory has to be done and straight line theory I will do. So once these two are done, coordinate geometry will be more or less over. I saw the results of the poll. Most of the students want calculus first, but there is a substantial number of students who also need vectors and 3D. I will do vectors and 3D first because it's a small chapter which can be done in 1 or 2 weeks. Calculus, if we start, it will take a much longer time. It might take a month to finish the course fully. So we'll start with vectors and 3D and then we'll move to the calculus section of the course, right? So stay tuned, and if you like the content, please subscribe to the channel and share it with your friends. I'll be making much more of these playlists for JEE Advanced. So if you go through these playlists, you will have a good revision for your exams. So I hope that helps you all, and please keep learning. That's all for now. I'll see you next time.